like to share a few more comments about server hardware before we wrap up this unit. Let's talk about server power, environment, and a couple of other things just real quick. Now, as far as server power, we're going to get power from an outlet just like we do in desktop systems. In fact, we use the same power cords most often in server systems that we have in our desktop system. Some advanced servers that are designed with high power components in mind will use a special cord or a thicker gauge wire in order to allow more electricity into that server, but in general it's going to be the same. One thing that's going to be different is the fact that we are going to want to use UPSs or uninterruptible power supplies with every server. A desktop is designed to be shut down frequently, and so it doesn't always need a UPS. But a server, especially one that we're depending on for a 24-hour-a-day, 7-day-a-week service, we need to be sure that we can ensure uptime. Now, a UPS doesn't only act as a battery backup, but also performs some cleaning of the power input to the system. 120 volt AC is not a perfect signal, and there's a bit of garbage, a little bit of electrical jitter as we call it, in that line, which can be harmful to the power supplies and the rest of the system if it's run for an extended period of time. Similar to desktop systems, we're going to want to make sure that the power supplies of our server have enough power to power all of our components. And much like in desktops, where our primary power consumers are CPU, graphics cards, and drives, we have some of the same considerations in servers, except for now, rather than just one CPU, we may have 2 or 4 CPUs. And the CPUs in servers often have a higher TDP, a higher thermal design power, or a higher power draw than their desktop counterparts. While we may not have GPUs to worry about, we do have drives, and we may have a significantly larger number of hard drives in our servers than we do in our desktop systems. Now, while it's uncommon for graphics cards to exist in servers, with the prevalence of online gaming, online rendering, 3D programming, it's becoming more and more common for servers to have GPUs that are going to need more power than a standard system. We'll need to add all of that up and do the calculation to make sure that our power supplies have enough performance, enough wattage for our system as a whole. Similarly, once we know the wattage of our system, the wattage of our power supplies, we can plan our uninterruptible power supplies accordingly and make sure that they're providing enough electricity while they're running, as well as on battery backup, so that our system will run smoothly and stably. Another thing that we want to control as far as the hardware of a system goes is the environment that that system is running in. Realize that servers are going to be running constantly. They have no time to cool off, and they depend on the airflow through the system as well as the environment that they exist in to properly cool that system. Because of this, the temperature of the room that that server is in needs to be moderated. Most server rooms will use some form of air conditioning to reduce the temperature of the room so that the servers can draw cold air in through the front and exhaust it out the back. When designing larger server environments, engineers will actually do calculations as to how much heat the servers are going to produce. We measure that in BTU, or British Thermal Units. It's our standard measure of heat output, and you can actually get specifications from manufacturers of servers as to what the BTU output of a server is. Add that up for all of the servers in the room, and that will tell you how many BTUs of heat you need to remove with your cooling system. Then you can actually look at the cooling system, which will typically be measured in tons of BTUs that it can remove per given time, to make sure that it can actually remove all the heat that the servers are going to produce. Large data centers use what are called hot and cold aisles. Essentially, you have servers facing each other in an aisle that you can walk down, and cold air is brought into that aisle through vents. The servers then draw that cold air through their system with fans and exhaust it into a hot aisle, which is the return for the AC system. The AC system then draws in that hot air, cools it down with refrigerated gas, and returns it into the server room where the process begins over again. Consider with me for a moment the path that heat is going to take from where it starts all the way to where it ends. The main component that's going to be producing heat in a server is going to be the CPU. It creates heat because electrical current flowing down a wire that has resistance creates heat. Overcoming that resistance is what's producing heat in that CPU. The heat from the CPU is going to pass up to the thermal paste. That thermal compound is going to move heat into the metal of the heat sink. That heat sink is then going to move the heat away from the CPU, and air moving across that heat sink, usually forced by a fan, is then going to take some of that heat from the heat sink. Air is going to get warmer, and the hot air then is going to be expelled out the back of the case into the atmosphere of the room. If you have an AC system in place, the air in the atmosphere in the room, usually a hot aisle, is going to be drawn into the AC system, and the AC system is essentially a giant heat sink. The air is going to pass across fins in the AC system which are cooler than the air, thus drawing the temperature out of that air into the fins of the AC unit and out to an external radiator where atmospheric air is passed across the radiator, and that heat ultimately ends up out in the outside air. Humidity is another concern when we're talking about server environments. Realize that an environment that is too dry tends to build up static charges, whether that's people walking through the room and touching equipment where a shock may occur, or a static charge being built up in the server itself due to the spinning fans and the dust buildup on those fans. Either way, it's a bad day for a server if it gets an electrical shock like ESD. Just like ESD is a problem in the desktop environment, it's a problem in the server world, and more so because the parts in a server are more expensive, meaning that if we shock them with ESD, it's a significantly larger impact to our budget than if we were to shock a desktop component. Along with an environment that's too dry, an environment that's too wet or too humid is also a bad thing. A cold object in a humid environment will cause condensation. Condensation dripping into a server will again cause significant damage to that particular piece of equipment. So typically we want to keep our server rooms between 65 and 80 degrees Fahrenheit and our humidity between 40 and 60%. While we're on the topic of environmental controls, let's talk about fire suppression for a moment. Now obviously fire and servers don't mix very well. Now, while a server isn't necessarily going to catch on fire by itself, and the materials in a server are not particularly flammable, the possibility of a fire in the building materials in the server room is something to consider. The goal of a fire suppression system is to put the fire out without damaging the servers inside. You can imagine that a water-based sprinkler system in a server room would not accomplish that task very well. In fact, a small fire which may have not posed any threat to the servers would result in a complete and catastrophic destruction of all the servers in that room were a water sprinkler used. Instead of water, we tend to use an inert gas. The most common today is a CO2 system. CO2 will displace the oxygen in the room, put the fire out, and CO2 does no harm to the servers in that room. CO2 is also relatively safe for human occupants in the room. Unlike halon, which is an older system that displaced the oxygen but also had the tendency to displace oxygen in the lungs of any person in that room, CO2 can be absorbed and processed by the human body since it's what we breathe out. And while it may knock unconscious the people inside the room, it has much less likelihood of killing them than a halon system or a different inert gas. If you're considering buying a server, you may be asking a question, well, how do I get started? Where do I go? What do I get? In the desktop world, we often talk about building it yourself or buying it from a commercial dealer like Dell or HP. We have similar options in the server world. Now, because of the dependence on servers for stability and reliability, it's commonly advisable to buy a commercial system rather than building it yourself. HP, Dell, IBM, Lenovo, and Intel all offer commercial solutions for servers that are built, tested, and supported by their respective companies. However, if you do desire to build your own server, you can do that. Supermicro is a company that specializes in customizable hardware. They sell systems that have a case, motherboard, power supplies, and maybe a couple of RAID cards pre-configured so that all you need to do is add your own CPUs, memory, expansion cards, and drives, as well as an operating system to get yourself up and running. Of course, all the rules of building your own desktop, parts compatibility, budget, making sure you do it correctly, do it right, still apply to the server, but somewhat more so because the server is going to perform a more critical task than the desktop system. You can save a significant amount of money by building it yourself, on the order of thousands of dollars, but if you can't guarantee that it's going to have 100% uptime, it's not worth saving the money in building that server. The time that that server is up is going to be more valuable than the money that you saved by building it yourself. While we're on the topic of building and buying servers, realize that there are some companies out there who need more than just one server. In fact, they need hundreds of servers. In that case, there are companies that sell what are called data center blocks, and it's an entire 42U rack pre-configured with all of the networking, servers, etc. that you would need for your data center. It's a different level entirely from a single server to a data center block, but it is an option for those that need more power in a pre-configured package and on a shorter time frame.